start with the origins of rapid shutdown and what happened. And when I'm talking timelines, I'm talking 2005, 2006 is when people started taking real interest. Now, if you go back, the 1984 National Electrical Code was the first time that we had requirements for the installation of solar photovoltaic. Panel 4 got smart and put in an acronym quite a few code cycles ago now. So we don't have to say solar photovoltaic every time. The acronym PV is it all throughout the NEC, and that saves us from having to say all that. So 1984, and it was very limited, a couple of modules on a rooftop here and there, and it started to expand. And in the early 1990s, it really started to expand. And by 2000 or so, there was a lot of PV going in all across the country. Well, as any other emerging technology, not everything went smoothly. And one of the things that started happening is there was rooftop fires, unfortunately. DC current, as you know, when we're working with the AC waveform, it breaks 60 times a second, passing through zero. Everyone knows that. That's involved in the electrical industry. Well, DC doesn't do that. DC is flatline. And one of the problems with that is the DC arc, even at very small current levels, can become much harder than the AC arc can. And that's what was happening. In addition to that, we had the rapid expansion of these installations going on rooftop location. Eventually, what started happening? We started getting rooftop fires. And as we were having rooftop fires, responding fire departments became very concerned. And some of their concerns were the safety concerns for firefighters. And we'll talk about, I've broken this into two: firefighter safety concerns and policy not to access roof. And so one of the safety concerns was that we had these energized DC conductors going into a building, and people were of the misunderstanding that everything remained energized even with the power shut off. PV started to be looked at like this big demon on the rooftop that's going to create all kinds of problems, when really a PV system is a limited energy source. It can only provide the energy that it's capable of producing. And if everything is installed in accordance with the NEC and properly installed, properly sized, it can never overload the wiring because it's a limited power source. Well, that's easy for me to say, but firefighters entering a burning building didn't always agree with that. Then they had the other issue. Well, what about up on the rooftop? And there was two concerns with the rooftop. One was the shock hazard, and the other was the reaction hazard. And what's the reaction hazard? The reaction is people will tend to pull away from electric shock if they can. And so if you're on the edge of a rooftop and you pull away from the shock, the added hazard is you fall off the roof. Well, neither one of those is a very attractive item. So those concerns were in there as well. As a result of those safety concerns, some fire departments actually made it a policy that they would not enter a burning building that had rooftop PV, and certainly would not go on the roof of a building that had rooftop PV. So in some instances, what could have been confined to a very small rooftop area burning greatly expanded because firefighters wouldn't go on the roof to put it out. Well, now insurance companies started to get concerned as well. And they said, wait a minute, we're accepting a premium to insure this building with the understanding that emergency response personnel are going to respond to this building like they would to any other. And if there's a fire, they're going to put it out. Well, all these concerns kept growing. And some of these concerns were echoed to NFPA.